Welcome to solverfy.
So here in this problem we are given that the coefficient of static friction between the belt and the wheel is 0.3, and we have to calculate the force P such that the wheel is on the verge of turning and the moment M we are given as, which is applied on the wheel, is 300 Newton meter. So we'll be considering this free body diagram of the wheel first, that you can see in this figure, and this is the tension A and this is tension D. Now we'll be first deriving the relation between TA and TD. For that we'll be using the relation which is given by belt tension theory, and by using that theory we can say that the tension TD is equals to TA times e to the power mu theta. Here we have assumed that the tension TD is greater than TA. Now, in mu we are given as 0.3, where theta is the angle of wrap, and if you see the figure carefully, theta would be equals to 270 degree, and in radians its value will be 3 pi by 2. Now I'm going to plug all these value here in this equation. So TA as it is, e to the power mu is 0.3 times theta we have 3 pi by 2. Now we're going to simplify this and we'll get TD is equals to 4.112 times TA. Now we're going to apply the moment equilibrium equation at point B, and this is point B. So sigma MB, it should be equals to 0. Now the moment in the anti-clockwise direction will be taking it to be positive, and moment in clockwise direction will be taking negative. So this moment is anti-clock, so we'll get to positive 300 Newton meter plus TA times this radius. This radius we are given as 0.3 meter, so TA times 0.3 meter minus TD times 0.3 meter, and it would be equals to 0. Now from here we can write that TA minus TD will be equals to 300 Newton meter divided by 0.3, and from here we'll get TA minus TD as 1000. Now we have two equations, this one and this one, and there are two variables TA and TD. We're going to solve these two equations simultaneously, and we'll get the value of TA as 321.42 Newton, and TD will get this value as 1321.42 Newton. Actually I did a mistake here, it should be a minus sign here and a negative sign here. Now we're going to solve it further. Now next we'll be considering the free body diagram of the lever. Now this is the free body diagram of the lever. Now our aim was to calculate the value of force P. For that we can take moment, and we should take moment about point C, because the value for Cx and Cy we don't know, but we have TD and TA. Now if you calculate the moment about point C, so the moment because of these forces Cx and Cy would be 0, so it would be better to take the moment about point C. So sigma MC would be equals to 0. Now the moment in the anti-clockwise direction will be taking it to be positive, and in the clockwise direction will be taking it to be negative. So first is this one, TD times this, which is in anti-clockwise direction, so we're going to be take it to be positive. So TD times this horizontal distance between point C and D is 25 mm. So let's convert the unit in meters, so times 0.025 meter. Similarly, TA times this distance is 0.06 meter minus P times this perpendicular distance is 700 mm, that means 0.7 meter, and it would be equals to 0. So we know TD and TA, so we can plug it here. So TD we have calculated as 1.42 Newton. Let me write again. This is 1.42 Newton times the distance is 0.025 meter minus TA we have calculated as 321.42 Newton times the perpendicular distance is 0.06 minus P times this one is 0.7 meter and it would be equals to 0. Now we're going to simplify this for P and we'll get the value of P as 19.64 Newton. So this is the final answer for the given problem which was asked in the question, that is the value of P. So I hope you have understood the problem. Thank you.